Okay, so last class on Friday, we started learning the rules for determining the number of significant figures. So you should have this first one written down. So all non-zero digits are significant. Okay. So your example is the number 356. All three of those are significant. Okay, so 3 SF means 3 sig figs. Then there's 4 more rules. These pictures, they are your rules. So if you haven't written them down yet, you need to write them down. So the first rule is the sandwiched 0. Okay. Your example is 402. So do you see how the 2, it is sandwiched in there? Okay. It's significant then. So then for this one, it's still 3 sig figs, right? The 4, the 0, the 2, they're all significant. Our next one, trailing zeros with a decimal, they are significant, okay? So think about it. If you take the time to write 3.00, if you took the time to write this, they must be significant. Okay. So this example also has 3 sig figs. Our fourth rule is trailing zeros without a decimal. Okay, so if there's no decimal point, these zeros are not significant. So then only 3 is the significant figure. So this one is only 1 significant figure. And then our final rule is leading zeros. Okay, so leading zeros, these are not significant. They're just placeholders. So these zeros we don't count, but the 7 is significant. So 0.07 would have 1 sig fig. All right, so the zeros are the tricky ones. So we're going to look a little bit more at those zeros. Okay, so take a look at the line up there on the ruler. And I think you have the same line on your student doc, yes? Okay, how would you measure that line? Like if you had to measure it, what number would you think it is? Okay, and it's all digits we know plus, how many do you estimate? Okay, 1, so it should be 50.0, right? If it's exactly 50. Okay, so in this line, we think it's exactly 50, so it's 50.0. Okay, the 0 at the end of the number, it's significant if there's a decimal. Okay, so if we write it as 50.0, okay, there's a decimal there, so yes, they're both significant. Okay, so all 3 of these digits are significant, so then there's 3 sig figs in that measurement. Okay, so now go ahead and look at this line. How would you measure like this line to be? 50, right? It looks about halfway, so it's just 50. Are we positive on the 50, or is it just a guess? It's just a guess, okay? So this time, we're guessing that it's 50, so it's just 50, 50, no decimal. Okay. So even though there's 2 digits in 50, there's only 1 significant figure, okay? So without a decimal point, that 0 is not significant. And the reason for that is, are we positive it's at the 50, or are we just guessing? We're just guessing, okay? We could be off, so it's just 1 significant figure. Okay, so let's talk some exceptions to sig figs. So one exception is counting numbers. Okay. If we were to count the number of people in this room, there's 21 of us in this room, okay? Can there be like 0.5 or 0.76 of us? No, right? There's exactly 21 of us. If you have a counting number, we don't count it for sig figs, because if there's 21 of us, could I write 21.000? Could I just keep going with zeros? Because there's exactly 21 of us. These technically have an infinite number of sig figs, and it means that we could write 0.000 for forever and ever, okay? So when we count numbers, we don't consider them like part of sig figs because they're exact. They're not estimates. Okay. Another example is using the number 1 in a conversion factor. So maybe even when I see you next time, we'll start looking at conversion factors. An example would be like 1 mole of hydrochloric acid weighs 36.56 grams. 36.56, does this look like a measurement?
Yes.
Yes, this is a measurement. That one does count for sig figs. So this number counts for 4 sig figs. However, this number 1, that is just saying like a 1 in the conversion factor. We don't count it for sig figs. So I'm just going to say no SF for sig figs. And then finally, when we have definitions that we use, we don't count definitions as sig figs. So example, a dozen is defined as how many? 12. Okay. And again, it's exactly 12. So we could always write it as like 1 dozen. It's exactly 12.00, right? Could we keep going with zeros? Okay. So because of that, we don't count it for sig figs. Okay. Another example we'll use is a foot is always how many inches? 12. Okay. So any sort of definitions, we don't factor in and count them for sig figs. Okay. So now we're going to practice. We're just going to look at each of these numbers, and we're going to count the number of sig figs. So 123, how many sig figs? Okay, good. 3 sig figs. All right, how about 0.123? 3 or 4. Look at our rules. What's the rule for leading zeros? Does this first 0 count? Okay, it doesn't. So how many sig figs?
3.
Good. How about 40,506?
What would you like to convert?
5 sig figs, yes? Okay, 40,500, this is the sandwich rule, and this is the sandwich rule. Okay, so all of those digits count. So there's 5 sig figs. Okay, 9.8000 times 10 to the 4th. When you look at scientific notation, this part you don't count as sig figs. Okay, so you can essentially ignore this part. So then if you look at this number, how many sig figs are in 9.8000? So this one's going to be 5. Okay. Whenever you have zeros that come after the decimal, they're significant. Also, I always think of it as if you took the time to write 9.8000 rather than just 9.8, they must be important, right? Okay, so this one is going to be 5 sig figs. What do you think for 4.5600? Good. 5 for this one. Okay, 22 meter sticks. I'm going to give you a hint. This is one of those exceptions. Okay. We don't count them. Is 22 a low enough number where I could actually count 22 meter sticks?
Yes.
Okay. So if it's a low enough number, like where you would actually count it, we would call this one infinite. Because could I write 22.00000 and keep going? Sure. The rule of thumb for this, if it's a number low enough where you would actually count to that number, you can do it as an exact count. If it's a number like you would get bored and move on with your life, it's too high, it's a measurement. Okay, so like theoretically, could you count to 300? Okay, but would you actually take the time to count 300 meter sticks?
No.
No. So if it's a number like that, it's going to be a measurement. 22, would you actually count 22? Yes. Okay. Okay, 0.07, 080. This is a tricky one.
2?
Take a guess.
I'm guessing
3. 5.
2, 3, 5. None of those.
1?
Okay, let's break this one up. The leading zeros, 0.0, do these count?
No.
No. Then we have 708, the sandwich 0, does it count?
Yes.
Yes. And then the end 0 after the decimal, does it count?
Yes.
Yes. So everything, the 7 and on count. So how many sig figs?
4.
4. Okay, and then 98,000, no decimal point. Just 2, just the 9 and the 8.
Okay.
Go ahead and take a look at the rulers on your page. So I know it's tempting to look at my screen. Don't look at my screen quite yet. So you're going to measure those 3 lines on your page. Okay. We're practicing using our measuring with sig figs. So it's every digit you know plus how many digits do you estimate? Plus 1. Okay. And then off to the side, you're going to write how many sig figs are in that measurement. Okay, so take a look at the first one. What kind of number did you measure for that first one? Say it.
88.9.
Okay, so like 88.9.
I got 88.33.
88.33. How do we know? So take a look at the scale. Oops, let's see. Okay.
It's right next to 89, but not right below it.
Okay, so check this out. So here's 80. What does each little individual line represent? 1. So then we know this is 85, 86, 87, 88, 89. Okay. So are we positive it's in between 88 and 89? Good. So we're sure it's 88 something, and then to me it looks like it's past the halfway mark. Okay. So then you make a guess on that last digit. Okay. So for mine, I have 88.8. Are you somewhere in that ballpark? Okay. And then how many sig figs are in 88.8? 3. Okay, all 3 of those digits count. Okay, take a look at your second ruler. What are you estimating for your length?
42.
Okay, like 40. Did anyone do 30?
I did 39.
Okay, let's talk about how many digits you should have. If I guessed 40, am I even certain it's in the 40, or is the 4 itself a guess? Okay, the 4 itself is a guess, right? Like, there's nothing that even tells you it's the 40. And how many digits are you allowed to guess on? Just 1. So your answer on this one has to be in the tens place. So you could have gone 30. You could have gone 40. Okay, but you can't be like 38 because you'd have to be certain on the 3 in RU. Okay, so you have to be the tens place. If I guessed 40 without a decimal point, is that 0 significant? No, right? No decimal. So only 1 sig fig. And the reason for that is this 40, it's a generous guess, right? Like it's not very accurate, so it's only 1 sig fig. I'm not certain about that 0. Okay, and then take a look at your third ruler. What did you measure your third one to be?
56.
Okay, like 56. Any other numbers? 57. I guess 55, right? Are we positive it's 50 something? Okay, so then you just guess that next digit. So I'm like 55, 56, 57. And how many sig figs are in that number? 2. Okay, are we feeling okay?
Yep.
Okay, so let's look at this measurement of 15. Okay, so let's say you have 15 centimeters. How many sig figs are in the number 15? Okay, so just 2. Okay. So remember when we do a measurement, all of our digits are certain except how many? How many are estimated? Just 1. Okay. So in the number 15, which digit is the one that we're certain about? Okay, so the 1. And then which digit is estimated? The 5. Okay. And then the last part is like draw a portion of the scale used for this measurement. So if we came up with a measurement of 15, our scale would have to look like this. So where I would know it's in the tens place, but then there couldn't be marks for the 5 since that's what I guessed. And if we wanted to draw the line we're measuring should look something like that. So this time we're looking at a measurement of 7.89 centimeters. How many sig figs are in 7.89?
3.
Okay, 3 sig figs. Which of those numbers are we certain about?
7.
7 and
The 8.
the 8. And then which digit are we estimating?
The 9.
The 9. Okay. So always the last digit is the estimated one. Okay. And then draw a portion of the scale used for this one. If we can measure 7.89, it means you have to have little marks at the tens place. Okay, so here's 7, here's 8. Each little line is the tens place. So then if we were going to draw like the line, and you don't have to draw the line, but the line would look something like that. Okay, so it goes all the way past 7.8, but not quite to 7.9. So on this slide, there's nothing to write down. I just want you to chat with the people at your table. Okay, so look at these measurements. We have 10 centimeters, 10.0 centimeters, 10.00 centimeters, and 10.000 centimeters. So with the people you're sitting near, go over what's the difference between those four measurements. What's the difference between these four measurements? What are we coming up with for the difference?
One of them is sandwich.
Okay, do they all have different number of sig figs? Okay, and we've been looking at a lot of rulers lately, right? Are they all going to be measured with a different ruler?
Yep.
Okay, so they're all going to come from a different instrument that has more or less precision, right? If you are just the 10, it's like that one just 0 to 100, right? Where you're just guessing. Okay, 10.0, you'd have lines like on the ones. Okay, 10.00, you would have lines in the tenths. If you got 10.000, you'd have lines for in the hundredth spot. Okay, so where we're going next is we're going to look at sig figs and calculations. Okay, so now we're going to look at when we start adding, subtracting, multiplying, or dividing numbers, how do we know how many sig figs should be in your final answer? Okay, so you should have a place in your notes that says sig figs and calculations, yes?
Yes.
Okay, so our first rule is if you're doing addition or subtraction. Okay, so if you're adding or subtracting, your answer has to have the same number of decimal places as the measurement with the least number of decimal places. How I remember this one, so if any of you need like a little trick on how to remember these, addition has D's in it, and I think D for decimal. Okay, so adding, subtracting, they go hand in hand, right? So I think D's in addition, D's for decimal. Okay, so then we're going to do these two practice problems together. So if you have your calculator, will you go ahead and type these numbers in your calculator? So 4.3 plus 5.20 plus 11.78. And then if you get an answer, will someone just read out whatever answer your calculator gives you?
9.98, 21.28.
Okay, so we're getting 21.28. Okay, so now we're going to look at, well, how many sig figs can our final answer have? Okay, so if you're adding, you're counting decimal places. Okay, so how many decimals in this number?
1.
Okay, 1. How about this number? 2. This number? Okay, your number can only have the least amount, which was 1. Okay, so that means your answer can only have 1 decimal in it. Okay. So then our next step, that first decimal is right here at the 0.2. Okay, you have to look at that next digit to figure out if you're going to round it up or down. Okay, so that next digit is an 8. So is that going to cause you to round it up or down? Up. So that 2 rounds up to 3. So you're going to round this to 21.3.
I gotta find the equal sign. 21.3.
Okay, you with me so far?
I think so.
Okay, let's do that next one. 15.99 minus 5.5. So if you have your calculator, go ahead and put it in exactly how you see it. And then will someone read their answer to me? 10.48? 49? Okay, so then now we're going to go through and we're going to figure out how we round it. If you are subtracting, you're counting decimals. How many decimals are in here?
2.
Okay, how many here?
1.
1, so how many can your answer have?
1.1.
Okay. So then the 0.4 is your 1. However, you have to look at the 9. Is that 9 going to cause you to round up or down? Up. So what does that 4 round up to?
5.
Okay, so you're going to round this to 10.5. Okay, so now we're going to look at multiplication and division. Okay. So if you're multiplying or dividing, your answer has to have the same number of sig figs as the least precise measurement in the calculation.
Come on.
Okay, so let's do our first example. Go ahead and type in 5.25 times 6.0. Okay, what are you getting in your calculator? 31.5? Okay, so now we have to figure out how are we going to round it. When you are multiplying, you're counting sig figs. So how many sig figs are in 5.25? 3. How about 6.0?
1, 2.
2.
Or 2, sorry.
Okay, so how many can your answer have? 2, whatever that least number is. Okay, so then the way you round it, you go to that second sig fig. Okay, so the 1 is your second sig fig. But you have to look at that next digit to tell you if you round up or down. If it's a 5 or greater, you're going to round it up. Okay, so since this is 0.5, you round up. So that 1 rounds up to a 2. So you're going to round this to 32.
Whoa, that's very big.
Okay, are you ready for the division one? Okay, 25.0 divided by 5.0. Okay, your calculator just gives you the number 5, correct? Okay, we still have to count sig figs. How many sig figs are in 25.0? 3. How about 5.0? 2. So how many should your answer have? 2. Your calculator only gave you 1 though. So what are you going to do to make it 2? You need to add a 0.0 to it. Okay, so really quick, just some rounding rules. Okay, if your decimal is under 5, you're going to end up rounding down. Okay. If your decimal is 5 and up, you're going to end up rounding up. Okay, so that's just, we're going to keep it simple. 5 and higher, round up. Anything less than 5, round down. So some examples. Let's say you have 25.5. Okay. So this 5 causes this number to round up. So this changes just to 26. Okay. Another example, 13.3. So this 3 is going to cause that 3 to round down, and that means it just stays the same. Okay, so it just rounds down to 13. We're going to do 4 practice problems together. So the first one we're adding, so go ahead and type in 79.6 plus 0.0168. And what do you end up getting?
79.6168.
Okay, so we end up getting 79.6168. Okay. So now we have to go back and look at our rules. So you're adding, are you counting decimals or sig figs? Okay. Decimals. Okay, so you're counting decimals. How many decimals are in 79.6?
1.
Okay, 1. How many are in this number?
4.
Okay, way more than 1. So how many decimals can your answer have?
1.
Just 1. Okay, so that first decimal is that 6, so 0.6. And then if you round up or down, you look at the next number. So do you round it up or down? Down. So what is this one going to become? Okay, so this becomes 79.6. This time I gave you units, so we'll keep our units. So 79.6 milliliters. Okay, our next one, 420 minus 19.11. So go ahead and type that into your calculator. And what do you end up getting? Okay, 400.89. Okay, you are subtracting. So are you doing sig figs or decimals? Okay, decimals. Does 420 have any? Okay, no decimals. So how many can your answer have? 0. Okay. If 420 doesn't have any, your answer can't have any. Do you even have to bother the time to count this number? No, your answer can't have any decimals. So for rounding, you have to go to the ones column, right? Because there isn't going to be any decimal. Okay. So then you look at this 8. Is that going to cause you to round up or down? Up. So 400 is going to round to 401. And I'm going to keep centimeters for our unit. All right, are we doing okay so far? Okay. Next, we have 6.77 kilograms times 0.9 kilograms. What are we getting? What are you getting? 6.093. Okay, you are multiplying. So are you counting sig figs or decimals? Okay, sig figs. How many are in 6.77? 3. How about 0.9? 2. Just one. That for 0. So just one. So how many can your answer have? Just one. Okay. So here's that first sig fig. Okay. And then I look at the next digit to see if I round it up or down. So it's a 0. So how are we going to round this?
6.1.
Just 6, because you can only have one.
Right, my bad.
One sig fig. Okay. What's a kilogram times a kilogram? Good. Kilogram squared. Okay. And then our last one, 56.200 divided by 260.5. Okay, what are we getting?
0.215738.
Okay, that's good enough. We're going to round it, right? Okay, you're dividing. Are you counting sig figs or decimals? Okay, sig figs. How many are in 56.200? 5. How about 260.5? Okay, so how many in your answer? 4. Okay, so we're going to count that fourth sig fig. Okay, so that's where the 7 is. And so then you look at your next digit. Is that 3 going to cause you to round it up or keep it where it is? Keep it. So 0.2157. Okay. If you have a gram divided by a gram, what happens? They cancel, so this one, just a number. The last thing we'll talk about is just converting temperatures. Okay. So on your notes, did I give you these equations?
Yes.
Okay, I will always give you these equations, so you don't need to memorize them. You just need to know how to use them. Okay. So we'll convert temperatures in here. So what unit do we usually prefer our temperature to be in? Okay, Fahrenheit. When you take measurements in our classroom with our thermometers, what unit is it going to be in? Okay, Celsius. And then we will hit a couple units like with gas laws where it has to be in Kelvin. Okay. So we have to know how do we convert between Fahrenheit, Celsius, and Kelvin. So we have 4 conversions over here. So we're going to practice just on the right. Okay, so let's say we have 68 degrees Fahrenheit, and we need to convert that to Celsius. Okay. So first thing, you just have to figure out what equation do you use. So if you look at the equations on the left, which equation do you think is the appropriate one to use? Okay, I'm hearing a lot of you just mumble it. You're given Fahrenheit and you're solving for Celsius. Okay, so it's got to be one of these that you're solving for Celsius. You're not given Kelvin, right? So you have to use this one. Okay, so we're going to use that third equation. And I'm just going to plug it in. So instead of degrees Fahrenheit, I'm going to actually plug in the 68 degrees Fahrenheit. We're going to minus 32. And then we'll multiply it by 5/9. So if you want, can you type it in your calculator just like that, all in one shot? Okay, I'm going to chunk it for right now just so I can show you sig figs. Okay. So what's 68 minus 32? Okay, so this first one is just 36. Okay. If you're subtracting, notice no decimals, so it's still 36. And then just timesing it by 5/9. So what do you end up getting?
$20.
20? Do y'all agree?
Yeah.
Okay. 36 has how many sig figs?
2.
2 sig figs for 36. And you're multiplying right here, so your answer should have 2 sig figs. So we just need to turn 20 into 2 sig figs. All you have to do is just add a little decimal point. Okay, so by adding that one little decimal point, it changes it to 2 sig figs, and then we can just give it a unit. Okay, so converting temperatures, sig figs can sometimes get messy. So my really basic rule of thumb is however many sig figs you start with, you need to have that many in your answer. Okay, so it's my simple rule of thumb. Okay, let's do one more. So let's say we have something that's 90 degrees Fahrenheit, and we want to know how many kelvins that is. Okay. If you look at the 4 equations over here, is there an equation that takes you from Fahrenheit to Kelvin directly? No. Okay, what unit do you have to convert into in between? Okay, so we're going to go from, we're going to go from Fahrenheit to Celsius to Kelvin. Okay, so we're going to use that same third equation to get to Celsius. So we're going to take our degrees Fahrenheit minus 32 times 5 nines. Okay, and if you want to save time, you can just type it all in at once. So what are you getting from your calculator all at one time? 32. Okay. 32.22, 222. Okay. Are you getting 32.22? Okay. And we don't want to round to the very end. Okay, so you can keep your calculator with all of its 2's. Okay. So that's going to be degrees Celsius. So now if you look at your equations, how do we get from Celsius to Kelvin? Okay, top one. What are you going to add to that number? Okay, so now we're going to take this 32.22. If you can copy and paste on your calculator or just add plus 273, go for it. We do not want to round until the very end. All right, so what do you get? 305.22? Okay. Do y'all agree with that number? Okay, so then my rule of thumb for temperatures, however many sig figs you start with is what you need to end with. Okay, so 90 with a decimal point is how many sig figs? 2. So we now need to round this to 2 sig figs. So the second sig fig here is really where the 0 is, and we look to that 5. Is that 5 going to cause you to round up or to keep it the same? Up. So we're going to round this to 310 Kelvin.